Okay, that's okay. So we are going now to start our new topic, distributions. Okay, stroke inferential statistics. Okay, so under inferential statistics, we also have distributions. Okay, and also hypothesis testing. And for us, that is our main focus. We are going to discuss about different that is types of distribution, and we'll only concentrate with the four major that is types of distributions. Okay, that is the first one, the normal distribution. Normal distribution. We'll also discuss on we have normal distribution, we have binomial distribution. We'll also discuss about binary. I guess its spelling is almost bi binary. That is binary. Can't it's can't I'll check on the spellings. Then we have another distribution known as Poisson distribution. Okay, we have Poisson distribution. So these are the major four distributions which we are going to discuss during our class. Okay, then maybe at your own time you can go and that is discuss about exponential distribution. Okay, exponential distribution. We have very many types of distributions, even up to what we call mixtures. Okay, up to what we call mixtures and the advanced level of distributions. Okay, mixtures basically it's a combination of uh, two or more distributions. Okay, like for example, we have that is a mixture of normal distribution, normal distribution, and that is Poisson distribution. Okay, remember this is a continuous distribution and this is a discrete distribution. So using mixtures, we can combine these two that is distributions and come up with a distribution known as Poisson inverse Gaussian. Poisson inverse Gaussian distribution. So basically, Gaussian, it's what? It is the normal distribution. It's another name for normal distribution. Okay. Yes. So under advanced level, we have what we call mixtures, which is basically a mixture of what? Of different distributions. And this is just an example of Poisson inverse Gaussian. And I've given it because it is this was my research work or my research paper. Okay, this was my research paper, and that is for the year, that is undergraduate. Okay, where I tried to model that is insurance claims, insurance claims using that is Poisson inverse Gaussian distribution. Okay, whereby um, I was trying to model that is the the claims, like how can we compensate the claims, okay, and also be able to have a reserve, okay, or reserve some money, okay, for investment, okay, or what amount of money should we reserve in case of future claims, and also to have a portion of it going to what? Going to investment, okay, so that it might be another source of money to the that is to the insurance company. Okay, yes, so basically these are the that is for distribution we are going to discuss. We are also going, remember we had that is mesh that is under central tendency or measures of that is, yes, under descriptive statistics. Remember, we had also a measure known as measures of asymmetry. Measures of asymmetry. And these measures of asymmetry, I say that we will now tackle it during what? Distribution. Why basically we are going to discuss about skewness, okay, and kurtosis. Skewness and kurtosis. So these are two, that is topic, topics we are going to as well discuss. So we are going to define this and this, okay. So my that is my objective is, if we can cover this, that is this week, okay, that is distribution and inferential statistics, then next week we can now finish, that is the class with now the last topic, which is sampling methods, okay. For sampling methods, remember I said we are only will only tackle, that is the theory part, of course, with some illustrations for what, about the four sampling methods, okay. So basically this will just take us one day, okay. So most of our work will be under what, and that is under that is distributions, okay. Yes, it will be under distributions. Okay, guess we are now good and ready to start. All right, just want us now to start with the distribution. And even before we can start, I know most of people know distribution from what? From its graphical representation. Okay, like we know this is normal distribution. Let me make it look a little bit better. Okay, we have normal distribution. We have another distribution which looks like this. That is uniform distribution. Okay, we have another distribution like this. Okay, we have another distribution which looks like it's like normal distribution but represented by what? By bar charts. Okay, we shall all check that. Okay, and then we have also another distribution, but it varies, like the Poisson distribution. We know this is binomial distribution, this is exponential, this can be in this form or this form. Okay, we have uniform distribution and we have normal distribution. Okay, all right, so before we can get to distribution, we usually talk about probability distribution. Okay, like what is probability distribution? Okay, and what does probability distribution that is present? Okay, because even when we are dealing with that is any distribution, here we shall calculate what we call probabilities. Okay, like the likelihood of maybe that is something happening. Of course, that is a probability. Okay, the likelihood of an outcome to happen. Okay, like for example, maybe let me just give you an example of a binomial distribution. Okay, so let's assume you are a basketballer. Okay, or you play basketball. Okay, and we have we have maybe some trials or research maybe we need to do. Okay, like let's assume this is you, this is the ball. Okay, like you can now calculate, given maybe 10 trials, you can now calculate the probability of having successful trials. So for successive, so in this case we'll only have two outcomes. Okay, a win or a fail. A win is when you take the ball through that is through this what pitch. Okay, a fail if you miss this that is basket pitch. Okay, so out of 10 trials, we might now decide to calculate what is the probability that 8 of 10 trials will be successful, or you will win 8 of 10 trials. Okay, also the probability that you will win 2 out of 10 trials. Okay, so after that, now that data which we've collected, we can model it. Okay, in terms of what, and also calculate what, those probabilities. Okay, so now the probabilities are the ones which we will use maybe to do what, to that is to show. Okay, to show maybe the type of distribution that data is assuming. Okay, yes, so probability distribution, I guess I have explained it well. So a probability distribution is a statistical function that describes that is all the possible that is values, okay, and likelihood that a random variable can take place, okay, within a given range. Like for example, when we are talking about binomial distribution, function of x, okay, like the probability of maybe x value, okay, and for binomial it will be given by n combine x, okay, multiply by probability of success raised by the number of successful outcomes, then 1 minus p, okay, to represent, okay, these are the what, the probability of not success raised to the total number of trials minus what, the successful that is the successful trials. Okay, so basically this will now give us probabilities for binomial distribution. Binomial distribution. Okay, for Poisson it will be that is a function of x or probability. This can be function of x or probability of x will be given by that is exponent of negative lambda. Okay, lambda basically this is a constant and it's always equal to the mean. Okay, so it will be exponent of negative lambda, lambda raised to x divided by what, x factorial. Okay, this is the probability function for Poisson distribution. Okay, maybe we might also have another one for normal distribution. I don't know if I can remember for normal distribution, but function for normal distribution is always 1 divided by that is 2 square root of that is square root of uh, pi, that is square root of pi, okay, square root of pi multiplied by exponent of negative 1 over that is 2 into or, okay, let me just make it simpler. Yes, here I forgot something. Here we have that is sigma, that is the standard deviation. Okay, negative into mu minus what? X bar divide by what? Divide by 2 squared. I guess this is the function for normal distribution. Okay, that is the probability function for normal distribution, if at all I remember. But you can confirm this. You can just confirm this. All right, so that's what we call probability distribution. So whatever the value which we'll get out of those function, they are values which are less than what? Less than 1. Because remember, for probability does not go beyond what? Beyond 1. Okay, all right. Then after now computing this probability distribution, we can now try to do what we call graphical representation of all those values which we got. Okay, so in case of that is after getting all those values, you will find that those functions or those probabilities tend to follow a specific what? Pattern. Okay, depending with the distribution that data set assumes. Okay, yes, so definitely it will be what? It will be it will assume a specific distribution. Okay, yes, so we are saying that probability is a statistical function that describes all the possible values and likelihood that a random variable can take within a given range. This range will be bounded between the minimum and maximum possible values. Okay, but precisely where the possible values is likely to be plotted on probability distribution, let's say graph, depends on the number of factors. These basically are the factors which affect what? That is a given distribution. Okay. Yes. Like for example, we have a standard deviation, we have skewness, and we have kurtosis. Okay. So basically, we'll see like how standard deviation affects what? Normal distribution. Okay. Meaning, if we keep maybe that is mean constant, what will happen to what? To our normal distribution. Okay, so definitely we will have what? We'll have that is different, that is peaks, and also different shapes. Okay, of the that is of the normal distribution. We shall see how we shall that is change the normal distribution. Okay, or we shall control normal distribution using that is mean and also standard deviation. Okay, you can see, and these are the factors which affect normal distribution. Okay, all right, then we have skewness and kurtosis. All these affect what? All these affect that is distribution. Okay, all the shape of a specific distribution. Don't worry, I shall illustrate how this affects that is the normal all the different distributions. Okay, yes, then we have types of probability distributions. Okay, there are many different classification of probability distribution. Some of them include normal distribution, we have chi-square distribution, we have binomial distribution, Poisson distribution, student T distribution. All those, I guess, maybe for those who are intermediate, when it comes to statistics, they learned about that back in what? Back in that is university. But as for this class, I've said we are going to focus on normal distribution, binomial distribution, Poisson distribution, and Bernoulli distribution. Okay, so the different probability distribution serve different purposes and represent different generation processes. Okay, like for example, the binomial distribution, for example, evaluates a probability of an event occurring several times over a given number of trials. Okay, given the event's probability in each trial. That's why I gave that is an example of what? Basketball player. Okay. Yes, so and may be generated by keeping a track of how many free throws a basket player makes in a game. Where one is a basket, that is, if we give one if that is he gets the ball through the basket, and then zero when it's a miss. Like in this case, we have only two possible outcomes. It's either a win or a fail. Okay, it's either a success or a fail. Okay, or it's either yes or no. Okay, yes, so that's a, kind of distribution which models or which that is yes, models that or such kind of data. Okay, same another example, it's maybe if you are tossing a coin. If you are tossing a coin, we have two possible outcomes. Okay, it's either a head or a tail. So in that case, we can do what? We can say, or we can figure out maybe probability that maybe we'll have two, three, four, or 10 heads, maybe in what? In 10 flips. Okay. Yes. So these are just an example or examples of probability distribution. And for binomial distribution, you'll find that binomial, binary, and Poisson are discrete distributions. Okay. They are discrete distribution because here we are talking about number of events. Okay, or that is possible outcome. Like for example, if it's a draw through the basket, we can't have a zero point 0.5 trial. Okay, it's either one trial, two trials, three trials. Okay, like you can't have one and a half draw. Okay, yes, so in that case, we will be dealing with that is with whole numbers. So in that case, we will refer binomial distribution as a what? As a discrete distribution. Okay. Then we have Poisson. Poisson basically tries to show us that is the probability of a certain number of events occurring within a given period of time. So in this case, we have period of time, okay, and a what? And a Poisson distribution, okay. All right. It's like, for example, if we are trying to count the number of oscillations, okay, a pendulum will produce in maybe within 1 minute, okay. Yes, so with that you can see now we have what? We have that is a time frame, and then we have that is number of events that is occurring, and in that case it will be number of full oscillations. Okay. Yes, so it's either a full oscillation, we don't have a quarter oscillation. Okay. All right. Are we good up to that point? All right, I can see my network. Hello, hello. I can see my network kicked me out. At what point maybe did you lose me? Hello, what about now? Can you hear me? Hello, can you hear me now? Hello, hello.
Yes.
Yes,
Hello.
yes. At what point
Yes.
did you lose me? At what point? Hello. Can someone tell me at what point you that is you lost me? Hello, can you hear me, guys?
Yes, yes, we can hear you.
So at what point did you lose me? Hello, Ado.
Hello, you are explaining
Mm-hmm.
binomial distribution. You said it's a discrete as opposed to continuous, since it only have one or zero as a valid response. That was your last part.
Okay, okay, that's okay. I guess I did not that I had given an example of the basket and also tossing a coin. Had I had given that
Ye-
example?
yes, yes, yes.
All right, okay, that's okay. So I want us now maybe to go to some takeaways of probability distribution, and then that is I'll just introduce normal distribution. Okay. Then after normal distribution, it's when now I will talk about what? I will talk about skewness and kurtosis. Okay. All right. Good. Any question up to that point? Was the introductory part that is clear? By show of thumbs, was the introductory part that is clear? Okay, Collins, it was clear. Mohammed, Adwo, okay, Ahmed. All right, all right. That's okay if it was clear. Good. Now let's continue. So, takeaways of what we've already discussed. That is, a probability distribution depicts the expected outcomes of possible values for what? For a given data generating process. Also, probability distribution comes in many shapes with different characteristics. Okay, and it can be that is defined or affected by these four factors. That is the mean, the standard deviation, skewness, and kurtosis. Okay, then we've said that maybe investors mostly use probability distributions, okay, to anticipate returns on assets such as what stocks over time, and to hedge their risk. Like for example, you can see, like you can model your your returns or your asset returns. Okay, then you'll see maybe previously how maybe a specific asset has been performing when it comes to that is investment return. Okay, then after that you can now do what you can now that is you can now try to model and see maybe what that is the future. Okay, or how the future will look like. Okay, all right, good. Let's now continue. So we'll start with normal distribution. So for normal distribution, of course, it is a bell-like distribution. I said that is the other name for normal distribution. It is what? It is bell shaped distribution or Gaussian distribution. Okay, Gaussian. That is Gaussian distribution. Okay, yes, and we shall also learn about properties of normal distribution. Properties. So under the properties of normal distribution, okay, this is now the area which will be tested. Come at the end of what? Of the that is of the class, like during your what, your final certification exam. Mostly you'll be tested on what? On the properties of distribution. Like it you might be asked like which distribution that is its mean is equal to mod and it's equal to median. Okay, mod, mean, and median is what? Is equal. Okay, so with that now, depending with what? With the properties of each distribution, you'll be able to that is give like and that is the answer of that distribution. Okay, then you might be given an illustration and then be asked, given this kind of data, which distribution or which kind of distribution will best model that data. Okay, yes, so be keen with the properties, and the properties is what will be majorly that is tested. Okay, and also understand it, because that is the point here is not all about passing maybe your final exams. Okay, we also need to talk about what? Talk about now you going forward with this knowledge and be able to apply it in a real world that is scenarios. Okay, all right, good. Let's continue. So we'll start with a normal distribution. Okay, so for a normal distribution, we are saying that it's also called it's also called the Gaussian distribution. Okay, and is the most significant continuous probability distribution. So you can see we've said it's what? It's a continuous probability distribution. Okay, so sometimes it's also called a bell shape. Okay, because of its bell kind of shape. Okay, that's why it is known as that is a bell shape. Okay, so a large number of random variable are either nearly or exactly distributed by what? By normal distribution. Yes, like for example, if we have that is a large data set, okay, of what? Maybe of people and their what? And their height. Okay, data for maybe height. Okay, data for we'll have data for that is weight. We can also have data for weight. We can also have data for maybe blood pressure. Okay, when it comes to hospitals, blood pressure. Why? Because in this case, you will find that we have few people who have maybe who are short when it comes to height. Okay, so we will have, like, for example, let me just have a good illustration. Like, for example, we'll have, let's say, two people of maybe, let's say, here we have the number, or that is the feet, that is the count in terms of feet. Okay, so you'll find maybe we have that is we have let's say uh, let's say two short people here. We might have two short people. We might have four or four people with what? Maybe this height. Okay, the same two. Maybe this height. This is it's in what? It's in feet form. Okay, we might also have other that is some more people with this height. Then you might have most of people are of what? Average height. Okay, most of the people you might find that they are of average height. Okay, that is most of the people. Okay, this is just to represent, like, most of the people are of what? That is medium size. Okay, then definitely you'll have some few people who are what? Who are tall. Okay, you'll get some few people who are tall. Okay, all right. And then maybe if we are to now, if we are to plot that data, okay, you'll get something like this, like a normal distribution. Okay, same thing to when it comes, let's say, in your class. Okay, if maybe you are given that is some tests. In fact, most of the tests you or most of that is cut tests, you heard that is your lecturers telling you definitely the results must follow what? A normal distribution, meaning we will have few people scoring S. Okay, we'll have majority averagely performing, and also we'll have few fails. Okay, for it now to follow a normal distribution, because not everyone can get A. Okay, we usually have some few A's. Most of the students average, maybe when it comes to the let's say a cut score, and then also few will do what? Will fail. Okay, so basically that is what? That is an example of what? Of a normal distribution. Okay, and if you can see from this, we've said it looks like a bell shape. You can see this looks like what? A bell shape. It looks like a bell. Okay, it looks like a bell. All right, good. Now that is a large number of random variables. Like, for example, we've talked about maybe cut marks, or maybe let's say height data. Okay, they will tend to follow what? They will tend to follow a normal distribution at a point. Okay, yes. So furthermore, it can be used to approximate other probability distributions. Okay, therefore supporting the usage of the word normal, as it is about one of the mostly used distributions. Okay, Yes. What about the properties of normal distribution? Okay. Properties of maybe a perfect normal distribution. So under normal distribution, that is the mean, the median, and the mode are what? Are equal. Mean, median, and mode are equal. Okay. Then the total area under the curve, like the total area under this, should be equal to what? To 1. Meaning at this point, it's where maybe we have the mean or the half of the what? Of this. And this is mostly for or that is for a perfect normal distribution. Remember, your data might be skewed, okay? Maybe to the left, okay, or to the right, meaning you'll have some tails to that is your tail will be long either to the right or to the left. Basically, this is the tail. Okay, this is the tail. So we will talk about when it comes to skewness, we'll talk about the long tail is on which side. Okay, and then when we'll be talking about kurtosis, we'll talk about the thickness, okay? The thickness or the thinness of the what? Of the tails, okay? Or fat and thin tails, okay? I will also explain that into details. All right. So we are saying that for normally distributed curve should be symmetric to the center, okay? Like it should be symmetric, meaning if we draw that is a line that is on the peak, it should divide these two into what? Into two equal parts. Okay. Yes, we are also saying that there should be uh, that is there should be exactly half the value are the right of the sender, and the other value that is half, it's what? To the left of the sender. I guess we've already discussed that. All right. Yes, we've already discussed that. Okay, so the normal distribution should be defined by the mean and standard deviation. Yes, like for example, we know that we usually say a distribution is normally or a data set is normally distributed with mean mu and standard deviation sigma squared. Okay, sorry, a variance sigma squared, meaning with a standard deviation of sigma. Okay, or square root, or that is a variance of sigma squared. Okay, yes. Then when it comes, we have another one known as standard normal distribution. So now for standard normal distribution, we know that the data is normally distributed with mean 0 and standard deviation what? 1. This is for standard normal distribution. Okay, that's why we are saying that normal distribution should be defined by mean and what? Standard deviation. Okay, yes, and then the curve sorry, the normal distribution curve should only have what? One peak. Yes, so for normal distribution we should only have one peak. Okay, let's assume it's like this. We'll only have one peak. Okay, this is right, this is not right. Okay, so this won't be a normal distribution because you can see like this, we have how many peaks? 3 peaks. Okay, for normal distribution we'll always have one peak. Correct. Then the curve approaches the x-axis, but it never touches, and it extends that is further from the what? From the mean. Basically, even you can see that is our what? Our illustration. Okay, the tails of the normal distribution are not touching what? Are not touching the x-axis. Rather, they are prolonging, okay, along this. Okay, all right, good. Any question up to that point? Yes, Collins. Collins on Terry. I can see your hands is up. We can't hear you. Okay, seems your mic has an issue. Is it possible maybe to type the question? Will it take you long to type the question? What about the rest? Are we okay up to that point? By show of thumbs, Ahmed, Susan, those are two. Rose, Deborah, Adwo, Steve, Chris. Yes, I guess we are good. Let's wait for. Okay, what do you mean when you say normal distribution should be defined by what? By mean and standard deviation. Yes, that's okay. So even from remember from our what? From even our function, the way we wrote that is the normal distribution. Okay, you can see what basically what value don't you have here? What value do you want to find? You have to find separately, okay, in this function. You can see it is only what? It is only standard deviation. Why? Because pi, we know pi is 22 divide by what? 22 divide by 7. Okay, then the other part you can see this is population mean and we have sample mean. Okay, we have population mean and sample mean. Okay, so in this case you can see we are trying what we are doing, it's like we are defining that is the function or the probability of normal distribution with these two parameters. Okay, that's the first one. Now when we talk about distribution, okay, what affects our distribution here? It's the mean, okay, like average, because we know in case maybe don't know if I have that illustration, but I will check that illustration. Okay, it's because like from this case you will know that in case of any change, in case of any change in mean, then the what? The normal distribution will shift, either that is if you decrease the mean. Okay, if you decrease the mean, the normal distribution curve will change to the what? To the left. If you increase maybe the mean, okay, if you increase the mean, then the sorry, it should not cut. So if you increase the mean, then the normal distribution curve, okay, will do what? Will change to the right. Okay, so when we say about normal distribution is that is defined by mean and standard deviation, it means these are the major two factors which affect normal distribution. Remember, we talked about some factors which affect normal distribution here during our introduction. So you can see this factor, like we have, these are factors that affect maybe the shape of the distribution of, or that is the shape of distribution. Okay, that is the average, which is the mean, the standard deviation, skewness, and kurtosis. So in this case we are saying that what that is the major two factors which affect the shape of normal distribution. It's what is mean and standard deviation. Okay, if we have variance in our data, so definitely that will affect the shape, okay, of normal distribution, or basically it will affect the distribution. Okay, yes, I don't know if that was clear. All right, that's okay. Any other question before I can end today's class?